How we doing, everybody? Dr. Stringer here, talking to you this week about Chapter 4, which is Module 5. We are going to be talking about some general issues in research design this week, in case you haven't already read your textbook. And so also remember that this week is your first lab assignment using the SPSS software. And if you haven't gotten that other SPSS book by now, you probably will need to rely a little bit more on the videos, but it shouldn't be too difficult. These labs are meant to get you acclimated with the software, get you to kind of be familiar with it, and they're not doing too much complicated analyses and stuff like that. So I'm going to talk a little bit about some general issues with research design. So let's think about causation, units, and time are key elements in planning a research study. And when you guys go later on to start writing your research proposals, you really need to think about these things. And if maybe you want to start thinking about how you're going to conduct your research already while we're talking about, or while you're listening to me talk about these things at least, like I said before in the first week of class, this is one of those classes that is really good to kind of have more class discussions and things about, which are kind of limited on our ability to do that in the online setting. But hopefully you all are finding it to be a successful experience. But anyway, yeah, so when we try to explain some phenomenon, it's kind of important to figure out how we're going to explain this and develop some sort of research design. I know that most of you have no interest in doing research whatsoever, but it is a required course, and so I do apologize for those of you that are like, I do not want to know anything about this, but, try to think of some, ways. This could help you if you want to go and read future research later. But think about, we usually try to focus our explanatory research on causation. The cause in social science is inherently problematic or probabilistic because it's very difficult to actually prove. Some factors make crime and delinquency more or less likely within some groups of people. There's the ideographic and the nomothetic explanations that the ideographic lists the many, perhaps unique considerations behind the action, and the nomothetic lists the most important and the fewest considerations that can explain this cause and effect. So, as posited by Shadis, Cook, Campbell in 2002, there's three main important criteria, and you probably want to remember this. That there must be an empirical relationship between two variables in order to prove causality. So this is not the most difficult part of proving this. We have plenty of statistical models that can show us that there is an empirical, statistically significant relationship between two variables. There has to be temporal order, meaning that the cause has to happen before the effect. You can't say that your house was destroyed if your house was destroyed before the hurricane came through, but then if it happened after the hurricane, then obviously you can say that the hurricane possibly caused it. The third one is the trickiest one of all, and that is that there are no alternative explanations. There are no spurious variables, so variables that might cause both of these things to happen that have absolutely nothing to do with what you have proven or what your relationship shows. The classic example of this is the ice cream issue in criminal justice. So the classic example is that ice cream sales are highly correlated with crime. And so we don't want to go on to say that, well, ice cream causes crime, right? And so you would say, well, actually, let's look at this then. Maybe there's something else that's causing both of these things to happen. That's a spurious effect. And so, of course, you might have already thought that it's perhaps because of the time of year. In the summertime, ice cream sales go up, and crime also increases in the summertime as well. So it has nothing to do with ice cream causing crime. And so this is why it's hard to actually rule that out, because sometimes there could be an alternative explanation that we don't know about. So that's even more challenging so people are very cautious about saying that one thing caused another, because it's really almost impossible to rule out all other alternative explanations. You can rule out the ones that you know about, but then there's going to be the ones that you don't know about that are impossible to rule out. So necessary and sufficient causes represents a condition that must be present for the effect to occur, but is not necessarily sufficient. So you must be charged in order to be convicted, but that doesn't necessarily mean that you will be convicted. It just has to happen. A sufficient means that it's going to happen, right? Pretty much guarantee that it'll happen. Pleading guilty is sufficient to being convicted, right? So that's sufficient. Validity and causal inferences. Scientists assess the truth, and validity and reliability are two important things. And I like to tell students, when you're thinking about the difference between validity and reliability, think about shooting a gun at a target. And if you shoot that gun and you hit the bullseye every time with each shot, then you have a valid sight that is on and it's reliable. But suppose you shoot the gun and then the shots are all over the target. Well, then it's not valid or reliable, right? Because it's not all over the place. But then you could have the instance where you have shots that are all in the same spot, but they're not in the bullseye. So that means that your sights are reliable. They're shooting all in the same spot, but they're not valid. Maybe their sights are off or something like that. You need to adjust them. So this is kind of how I like to explain validity and reliability. They're very important causes when it comes to thinking about causality, because you want to make sure that you're actually valid and reliable in your measurement. Are the two variables related to each other? We can't have as much confidence in statements about causes if their findings are based on a small number of cases. That gets into statistical power and things like that, which is a little bit, gets into statistics, so I won't bore you all too much with all of that. Now, internal validity is an important thing. Generally due to non-random or systematic error. The threat to internal validity, I can't tell. Results when the relationship between the variables arises from the effect of some third variable. So, like I said, the spurious effect. Or, for example, drug users sentenced to probation over prisons recidivate less. Well, of course, because your low-risk offenders are the ones that are getting probation instead of prison. The ones that are repeat offenders and stuff are getting the prison. So that's an important thing to control for, so to speak. We don't get too much into control variables in this course, but that's a way that you can actually fix that. So external validity is just another problem. And so these are all different types of validity that you'll find in your textbook. They go into much more detail about that, but those are threats to the findings that are kind of coming external, outside of the experiment. Do the findings apply equally in different settings? You might also think about it as kind of this idea of generalizability. If we conducted an experiment here in Kennesaw, with what we did in Kennesaw, would it apply to Kansas City or New York or Los Angeles, these other places? That's kind of the idea of external validity. Construct validity. This is how well your measures are operationalized. Remember, we talked about the difference between operationalization and your conceptualization. So you want to make sure that your construct validity is the best you possibly can be. As we talked about, or we didn't talk about in this class, but I think your textbook talks about the Kansas City Preventative Patrol Experiment and police visibility, and how that might have kind of impacted the validity of their findings, right? Here, generalizability, we've already kind of talked about that a little bit, these real-world behaviors and conditions. And you might have bias too, right? Now, you don't really have to worry so much about non-systematic bias because that won't affect your findings that much, but systematic bias can be more problematic because that'll affect your statistical outputs. Does drug use cause crime? Well, temporal order, for example, right? Well, the drug use has to come before the crime in order for drug use to cause crime. A statistical relationship exists, but the underlying causes affect both drug use and crime. That's a threat to internal validity, right? So what constitutes drug use? Crime. This is kind of your construct validity, right? We used this example earlier, right? How will policy affect drug use and crime? A crackdown on all drugs among all populations will do little to reduce serious crime, right? I don't know. Is it possible? So this is just an example of kind of framing a research question with hypotheses and then applying some of these issues of temporal order, validity, and things like that to it. I know this is kind of a lot and it's probably new to all of you, so it might take a little while to sink in. So the scientific realism talks about this ideographic and mnemothetic approaches to explain things by seeking to understand how the causal mechanisms operate. So sometimes you could have cause and effects that are simple, other times you can have reciprocal effects, other times you can have indirect relationships, whereas like one thing causes something else, which causes something else. So like, I don't know, from my drinking research, you might have drunk driving. You have people that drink and drive, but the drinking and driving doesn't cause a crash in and of itself, right? It's the drinking and driving that leads to the crash, that leads to the fatalities, right? And so it's not just the drinking and driving, it's the drinking and driving and being careless, and then, leading to the crash, which then oftentimes leads to injuries and fatalities. So they're kind of more attenuated, right? And for those of you that don't know, not all people that drink and drive cause fatal crashes, so that gets at that as well. So units of analysis. This is another important thing that you might want to remember. We have different units of analysis across the social sciences. You have individual level, which we call micro level units of analysis, and then you might have what we like to call meso level, which are kind of in the middle, which are kind of groups, organizations, things like that. And then at the very top you would have macro level units of analysis. So like if you're comparing one state to another or one country to another, very large units of analysis. The ecological fallacy is talking about applying things across different levels. So you don't want to make assertions about individuals based on the examinations of groups or aggregates. If we conduct an analysis that compares things across states, we don't want to then try to apply those results to the individuals within that state, because that's the definition of the ecological fallacy. We're looking at poor areas and poor people are two different things as well. Individual fallacy, looks at the O.J. Simpson case, might be a good example of that. Reductionism is actually the opposite of the ecological fallacy. So it's trying to make individual findings apply to larger groups. And then you have the time sequence. We've already kind of talked about that with the temporal ordering, but it's critical in causing that, because you can't say something caused something that happened before it. That's some of you might even call common sense, right? So that's kind of important. And we have a difference between cross-sectional studies and what is known as a longitudinal study. So a cross-sectional study is just studying one point in time. So maybe we might look at crime in 2019. That would be a cross-sectional study. Now, if we conducted a longitudinal study, which I believe is the next slide, that would be looking at things over time. So maybe you want to look at crime from 2000 to 2019 and see how it's changed over time. That might be something you might want to do. Or you could even do it within a person. So you want to follow individuals over time and see how their crimes change over time. You've probably heard of the age crime curve, that people tend to, at really young ages, they don't commit many crimes, and then around 18 to, mid-20s, there's kind of the peak, and then it kind of declines after that. Approximating longitudinal studies, there's some ways that you can do that, and your textbook talks a little bit about that too, to compare rates of gun ownership as reported in an international crime study to rates of homicide and suicide committed with guns. You can sometimes do what's called an accelerated longitudinal study, which is a little bit more advanced too, in order to try to conduct a longitudinal, because if you want to conduct a longitudinal study, it's going to take a long time, and a lot of people don't really want to waste all that time on one study because we've got other things to do, right? So retrospective research that asks people to recall their past for the purposes of approximating observations over time. That's kind of another way of kind of doing this accelerated longitudinal study, so you don't have to actually ask the person questions every year, but you can ask them about this year and the year before that and the year before that to kind of collect this longitudinal data without having to do it over a long period of time. Past records are also really good for this, like crime reports, people's criminal history and things like that. They're actually more reliable because people's memories can kind of get fuzzy sometimes. So thinking about the time dimension summarized, we usually call a cross-sectional study kind of a snapshot, an image of one point in time, and then the trend study is kind of more like a slideshow, and then the panel study is more like the motion picture that gives information about individual observations over time. Hopefully that was informational for you, and it'll help you to keep these things in mind. And I've gone over my 15 minutes, so I will talk to you all next week.